Okay, so today we're learning about similar triangles. We just talked about the fact that similar triangles are still going to be the same shape, but not necessarily the same what?
Size.
The same size, right? So one will be larger than the other, but we know if they are similar that their angle measures will still be the same. Okay, so here's some important information for you to know. If two angles in the triangle are the same measurement, then their third angle has to be the same measurement on both. Think about it. If you have one angle that's 100 and one angle that's 70, that's 170, your third angle has to be what? If those two angles are 170, what is the third angle? It has to be 10, right? So if two measures are 170 on both triangles, the third measure will be 10 on both triangles, correct? Okay, so I only have to match up two pairs. All right, so watch this. Is there a 65-degree angle on the other larger triangle?
Yes.
Yes, so that's one pair. All right, is there a 95-degree angle?
Yes.
Yep, so that's two pairs. So even if I did not know this third angle measure, okay, on either one, because the other two are 95 and 65, I know the third one has to be the same exact measurement on both. Does that make sense? It has to be, because they both have to equal 180. Okay? All right, so, and in this case, they would be 20. So, in the next example, I'm going to have two triangles. All right? And what I'm looking for is two angles that are the same measurement in both triangles. All right, so the first thing I'm going to look for is the angles that it tells me. Okay, so do you see on the first one, do you see a 50-degree angle right here on the first one?
Yes.
Is there a 50-degree angle on the second one? Okay, so I want you to circle them. That is one pair, okay? Now remember, I need two angles to be the same. So let's look at the other measurement they give me, 75. Is there a measurement over on the second one that's 75?
Yes.
So, without having to do any work, I know that my third angles, the X and the Y, have to be the same measurement without doing any work. Because 75 plus 50, can anybody just do that for me real quick? What's 75 plus 50? What is it? 125. Well, is it going to be any different over here? No, they're both going to be 125, which means my X and my Y will definitely be the same measurement to equal 180. So as long as I can prove that two pairs of angles are the same exact measurement, that means automatically the third one is, all three angles are the same. In this case, because I was able to verify that with the angles that it gave me, there is no work to show. All I have to say is yes, because there are two pairs of congruent, what does congruent mean? Equal angles. Okay? So what do you think, why, and let me ask it this way. Why do you think it is so important for you to explain your answer and not just say yes? You say, well, Ms. Skinner, I said yes because I looked and I found the two pairs, but if you don't say it, if you don't write it, what do I think when I'm grading your paper? Oh, I'm sorry. I think you what? I think you guessed. Yeah, I think you guessed. You just said, yes. Okay, so the reason why is very important because it shows me that you knew what you were looking for. Okay, so let's look at B now. Just by looking at the triangles, can you see one pair of congruent angles between the two triangles just by looking at them? Juvenette? 90. Very good. So one pair is the 90-degree angle. All right, so great. I have one pair, but I need two. So now I go to the next angle that it gave me, 42. Can I find a 42 on the second triangle? That doesn't mean, though, that they are not congruent because Y could be 42. I don't know. So now, because of the information they gave me and I can't tell, I must solve either for x. All right, if I solve for x here, I'm looking for it to be 38, right? I can either solve for x or I can solve for y. It doesn't matter, but you have to solve for one of them. All right, so let's just solve for x. Let's solve for x here. Do you guys think that you could solve for x, solve for an unknown angle of a triangle? Yes. Yeah, because we learned that in 3.2, right? Go ahead and set up your equation and solve for x. Solve for x. All right, so I have x plus 42 plus 90 equals 180. Okay? Did anybody just go ahead and add those together and then write it? What was 42 plus 90? 132. If you write it this way, that's fine. Okay? Equals 180. All right, now what would I do to both sides to solve for x? What would I do, Kyla? What would I do to both sides? Very good. Subtract 132. Okay, and now x equals 48 degrees. So I come back up here to my original triangle and I say, okay, I know these three angles are 42, 48, and 90. So over here, I have my 90, but do either one of these two match the other one? They don't. So there's no way. All right, again, one of those two would have had to be 38, and it's not. So my answer is no. More specifically, because there's only one pair of congruent angles. There was only one pair. The one triangle we just saw for did not have a 38-degree angle, did it? No, it had a 42 and a 48. Okay, any questions? Are you guys kind of following along? You see what we're doing here? Okay, you're going to have several homework questions like this tonight. All right, you cannot just say yes or no. You will lose major points on your homework assignment. You have to show your work. All right, example 2 is a little different because on example 2, I really don't see any angle measurements. So how in the world could I tell if triangles are similar, you guys paying attention, without angle measurements? That's weird. Okay, remember what we learned in 3.1 about corresponding angles? Corresponding angles, what do we know about their measurements? They're the same. So if there were a way to prove corresponding angles between two triangles, then I would know they would be the same measurement, right? Like if one corresponding angle was 40, then the other one would be 40. So that's a lot of the background behind how I can solve this. Let's look at the first yellow triangle. Do you see, okay, you see the sequence up here, JKL and JMN? Do y'all see that? Mm-hmm. Look how it outlines here, J, K, and L. Do you see how that's the little one? Mm-hmm. Okay, and then do you see J, M, and N? You see that one? That's the big one. Do you see how it's a little one inside a big one? You guys see that? Little inside a big one. All right. The other thing I need you to understand, this angle K, I really don't like where they wrote it, okay? Because angle K is this angle right here inside the little one. You see that? Because in order for it to be an angle, it's got to be inside the triangle, right? 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 It's got to be here. This is K, this is L, this is N, and this is M. All right? So I need to figure out if these triangles are similar, but I don't know any measurements. Look back to the sequence for a minute. JKL and JMN. Is there anything similar between the two sequences? J. All right, give me a value that looks like it maybe could be J. Don't say 90 because that's not a 90-degree angle. Well, what do you think? 80. More like 20. More like 20 or 30, right? So if J is 20 degrees on the little one, what's it going to be on the big one? It's going to be 20. So if there is a shared angle, okay, and this goes for all of the figures you're going to see, All right, angle J is one pair because it is shared between the two triangles. Angle J is shared, so that's one pair. Now I need you to look, okay, I'm going to go ahead and erase this so you can see the original figure. Do you see these two arrows right here on the lines? I didn't really get a chance to talk too much about those arrows. You see those arrows there on the two lines? Those arrows are very, look, pay attention, pay attention. They're significant because they say that they're parallel. Two lines are parallel. Now look what happens. Look at what we can do here. Parallel lines. Look what happens if I extend them a little bit. And look what happens if I extend the sides of my triangle a little bit. What does this look like now? Something from 3.1 perhaps?
Yes.
That looks like it's forming some corresponding angles there. Okay? So because the lines are parallel, remember how we said these angles are actually inside the triangles? K, M, L, and N. Do you see how K is in the bottom left section when I kind of extended my lines there? You see that, guys? Look up here. See how K is in the bottom left section? You see how M is in the bottom left section? Because those sides are parallel. If these arrows hadn't have been there, there's no way I could tell if these triangles were similar. But because the arrows are there, I know that K and M are corresponding. What does that mean about their measures? They're the same. So I don't need to know what they measure. If one is 80, the other one's going to be 80. If one is 75, the other one's going to be 75. So because they're corresponding, and by the way, L and N are also corresponding, I know that these are similar triangles. We proved it through angle relationships. Okay? Proved it through angle relationships. I think the second one's a little easier. Look at the second one. I've got one little triangle. Here's the little guy. And I've got one bigger triangle. And I want to know, are these triangles similar? Can I prove by just looking at these triangles that they have two pairs, not one, but two pairs of congruent angles? Can anybody tell me one pair? Possibly. Raise your hand, raise your hand, raise your hand. Can anybody tell me one pair here of congruent angles? Possibly. Kyla? Yes. And which ones are they? Which ones are they? Angle.
Angle Q and angle S.
Yes, ma'am. And angle S. Because, and I'll let you abbreviate it. Use the slash if you're going to abbreviate it. They are right angles, or you could just say they are 90 degrees. They're both. So that's one pair, but one pair is not enough. I have to prove that another angle in that triangle will be the exact same measurement on both triangles. Is there any way for me to prove that without knowing the measurements? If your answer is no, they're not similar. If your answer is yes, why? What do you think? Do you remember what we said about angle J in the first one? Do you remember what we said about angle J over here in the first one? Look at your sequence. Look at your sequence up here. Okay, so we said angle J was shared on the first one. Is there possibly a shared angle? Yes. Do you see R right here, guys, in the middle? Angle R is the same angle that connects both of them. So because of that, angle R is shared, which means whatever its measurement is on one triangle, it will be the exact same measurement on the other triangle. So I have proven that I have a shared angle and I have a 90-degree angle. So guess what? If angle R is 45 degrees, then angle R is 45 degrees. And guess what? My third angle up here has to be the same exact measurement. You see that? Guys, if you can get this, you get the whole lesson. Because I have 45, 90, 45, 90. The top ones have to be the exact same measurement to be 180. You see that? Mickey, do you see it? Trey? Michael? No? Okay, so look. If this one's 90 and this one's 45, can you add them together and subtract it from 180?
Yes.
Right? Couldn't you? So whatever that one is, now look. If this one's 45 and this one's 90, could you add them together and subtract from 180? Wouldn't it be the same thing? So they're similar. That's what I'm saying. I made it up. All I'm doing is just showing you whatever R is on one, it will be the exact same measurement on the other. I just made up 45. Okay, so I'll erase it. Is that what confused you? Because I just made up the 45? All right, guys, that's everything you need to know for chapter 3, really, as a whole, and section 3.4.